Okay, we are going to start with what is probably the most dreaded part of chemistry, but do not let other people scare you. It is very simple once you get the hang of it. Okay? And the key to getting the formulas and the naming correct is practice, practice, practice. Okay? I know you've heard it before, but it really helps in the case of chemical formulas and naming. Now we are going to start with ionic compounds first, before we get to molecular. So we're going to focus now just on ionic, and then we'll go on to molecular afterwards. There are rules when it comes to ionic bonding. The first thing to do is, let's say I tell you calcium and chloride react. So I'm telling you that you're going to have calcium and you're going to have chlorine react. What would the formula be? How do I know what ratio it's going to be in? First thing to do is write the charge of each. Calcium in its ionic state has a charge of +2. Chlorine has a charge of -1. So that's the first thing that you do. You write down the element, then write down its ionic charge. Then you do something called the crossover method. You take the number, not the charge, the number, and you crisscross. And that tells you the subscript of each element. So calcium, you take the 2, you put it at the bottom of the chlorine. The 1 you take and you put it as a subscript of calcium. Remember I mentioned before, we usually do not put 1 if it's only one element there. So the formula would be calcium chloride. And I'm going to talk about the naming in a moment. So that is how you do the formula. I'll talk about the name later. You do the crisscross method. Let's take another one. How about I give you aluminum and sulfur. Aluminum is in group 3, so it has a 3+ charge. Sulfur is in group 6, so it has a 2- charge. So how will I know how to write the formula? Crisscross. The 3 goes at the bottom of the sulfur, and the 2 goes at the bottom of the aluminum. Then you have Al, 2, S, 3. The reason we do the crisscross, and let me show you why, is the compound has to have a 0 charge. Okay? The compound has to have a 0 charge together. If aluminum has a +3 charge and sulfur has a 2- charge, let's see if this ratio would work. We have 2 aluminum. So we have 2 times a charge of +3. We have 3 sulfur, and each sulfur has a 2- charge. So we have 3 of a -2 charge. So we have a +6, -6. Yes, we end up with a 0 charge. That's why we use the crisscross method. It neutralizes the compound so it has a 0 charge. So whenever you're not sure whether you've done the crisscross method correctly, calculate the total charge. 2 aluminum gives me a +6 charge. 3 sulfur gives me a -6 charge, ending up with a 0 charge, which is thumbs up, you did it correctly. Okay? Now, how about naming? Okay, so we're going to talk a little bit about naming ionic compounds. It is actually quite straightforward. Okay, so what you do with ionic, you have your cation with an anion. How do you form the name? You take the name of the cation plus the name of the anion, but you add "-ide" to the name. So let me show you what that means. So what if I had NaCl? So Na is sodium, straight from the periodic table. Sodium. This is chlorine, but instead of chlorine, I say chloride. That's what I mean by adding the "-ide" onto the name of the anion. Let's try another example. How about if I gave you CaF2? Same rule. You take the name of the cation, which is calcium. You then take the name of the anion, which is fluorine, but you don't say fluorine, you will say fluoride. Calcium fluoride. With ionic compounds, you do not need to worry about how many of the anions you have. Okay? You just take the name of the cation plus the name of the anion, but you take the last letters and you change it to "-ide." The only time that this is going to be a little bit more tricky is when you deal with these wonderful metals called transition metals. I apologize for my dog barking in the middle of me trying to do this lesson. So, transition metals. These are metals that can actually have more than one charge, just to make your life a little bit more difficult. Okay? They can actually have sometimes a +2 or a +3, sometimes a +2 or a +4. So, depending on the type of compound that it's in, determines what kind of charge it will have. In those cases, you have to be very careful. So let's take, for example, copper. Copper is one of those metals that can have more than one charge. And copper can have the charge of +1 or +2. Okay? So it's one of those metals that can have either one. How do you know? Let's say I gave you a compound such as this. How do you know which copper am I using here? Is it the one with the +1 charge, or is it the one with the +2 charge? Well, what did I mention before? This entire compound has to have a 0 charge. Well, we know the charge of sulfur. We know sulfur is 2-. So what charge does this copper have to have in order for the whole compound to have a charge of 0? Of course, it would have to have a +2 charge. That is how we know we are dealing with the copper with a +2 charge. I could have given you this. Okay, let's work through this together. Again, sulfur's charge doesn't change. Sulfur has a charge of -2. But in this case, how many copper atoms do I have? I have 2. I have 2 copper atoms to balance out my -2 charge. So in this case, what charge does copper have to have if I need 2 of them to balance out a charge of -2? That means I am dealing with copper having the +1 charge, because 2 of them would then balance out my -2 charge. So that is how you determine which transition metal charge you are dealing with. Do the math. The whole compound has to have a 0 charge. So you know one of them is for sure. You know sulfur has -2. So be careful with the subscripts, because those can help you determine which charge you are dealing with. But then how do I name them? How can I tell the difference between the copper that has the +1 charge and the copper that has the +2 charge? Let's say we were dealing with this, which I know the copper had the +2 charge. You would write it as copper, and then parentheses, the Roman numeral 2. That tells you you are dealing with the copper transition metal whose cation has the +2 charge. And this is sulfur. Remember, when you use the name, it's not sulfur, it is sulfide. Remember the ide? So this is copper 2 sulfide. If I was dealing, excuse me, with the other formula I gave you, in this case we said that copper had the +1 charge, you would then write it as copper 1, Roman numeral, sulfide. So this Roman numeral is important when you are working with a transition metal. If you do not write the Roman numeral, you are not completing the formula correctly. Other transition metals are such as tin, lead, and the other ones in your periodic table. You will be given a list of the transition metals and their charges that you will need to know. So when you recognize that you have a transition metal, you'll know that you're dealing with a Roman numeral in the name.